Hey everybody, welcome back to the Print 3D channel. Today we've got a really cool project for you guys. This is the Open Press project, a 3D printable printing press. And we already assembled ours and we've gotten some awesome prints from it. And we're going to show you how to build it and how to print with it, so stick around. Hey everybody, welcome back, and thank you for joining me here on the Print 3D channel. Like I was saying in the introduction, we've got a really cool project for you guys today. This is the Open Press project, a 3D printable printing press. Now this is a really cool project because it harkens back to the original days of printing, before we had 3D printing. And I'm going to show you step by step on how we put ours together today and how we got some really great prints. Also, I'm going to show you guys how we can take Illustrator art, convert it to an SVG graphic, and bring it over into Tinkercad and print out our own plates for this cool little printing press. So before I show you some of the cool prints I was able to achieve with this cool open source 3D printable printing press, let's head over to the Open Press project and I'll show you where you can download your files and a brief overview of the assembly. Then we'll head over to Simplify 3D and I'll show you my settings for the prints. We'll check out a couple of time lapses I shot of the G-Max 1.5 XT Plus using Kodak 3D Printing's PLA Plus filament, printing out all the individual parts for the press. After that, we'll go over the assembly of the actual printing press and some other needed steps you'll need to do before you actually start printing. And then we'll come back here and we'll talk a little bit about the prints we were able to achieve with this really cool open source 3D printable printing press. So we've got a couple of things to cover, so let's head over to the Open Press project and I'll show you where you can download your files. Alright, so here we are on the computer and we are at openpressproject.com. And here's where you can download all your files. You can also see some prints by some other users who've printed out their own press and started printing with it. Plus there's some stuff about some events coming up, and I do believe they still have, I might be open till the end of January, but an open call for submissions for their Open Press collection. Now you can read all about the Open Press project here, but what we want to do is we want to print one. So we want to go to How to Print a Press, and we'll let that page load, and this will take a second. So here on the How to Print a Press project, you're going to see an exploded view of the entire printer, and this is your assembly guide, along with I'll show you how to do the assembly yourself. And it's going to tell you how to print out the parts, what you're going to need to do. You're going to need 2 of these side parts. You're going to have to duplicate this on the print bed. The rollers, we actually addressed those separately because they do require some support material, so that was a separate print. And of course the press table, the roller wrench, and the roller pin, we actually printed those out separately. And the connector parts, we have printed those with 2 parts with the actual side parts, and then the top part, I think I printed those with that section there. And now you can get an overview of what your press is going to look like once it's all assembled and ready to start printing. So once we have our files all downloaded, the next thing we're going to need to do is head over to Simplify 3D. So let's head over there now, and I'll show you my slicer settings for the 3 different build plates that we put together for our prints. Okay, so here we are in Simplify 3D, and this is the one of 3 build plates that I put together. Now the only reason why I did 3 different build plates is I wanted to address 3 different settings for each of the different prints. Some I wanted a different layer height and a different infill, and the others I wanted opposite of that. So I have 3 setup build plates, and plus I have one that's set up with support material, and I wanted to print that separately, and that's the rollers. So this first set is the side pieces and the 2 connectors that go with it, and I'll show you my settings for this print. We used a 0.24 millimeter layer height with 4 top layers, 3 bottom layers, and 3 perimeters. We also ran a skirt 10 millimeters from it at 4 outlines. For the infill, I always use fast honeycombs because that seems to be the strongest, and it does sometimes put an extra line of perimeter along the edges when you use fast honeycomb, so you get a little bit of extra thickness on the walls. At 25%, we didn't use any support material for this build plate. We are using Kodak's PLA Plus, and I found that 220 and between 218 and 220 are great temperatures to print with. We did utilize the excellent G-Max cooling and bring it all the way up to 85% in slight steps. And for the speed, we did print this out at 45 millimeters per second. And here you can see the different variables I've set up for the outline and the solid infill. Now we did use the allow single extrusion fill, which is one of my favorite settings in Simplify 3D, to help really strengthen up the walls in the smaller areas, because there is some bridging that's going on. So we did allow the apply bridge settings to perimeters setting under bridging, because there is one area where there's a slide that needs to move, and you want to make sure your bridge settings are really good for that, and your cooling. So if I hit prepare to print here real quick, you can see how this sliced up. So now that we have this sliced up, if I dial in through here, you can see that we do have some bridging going on because you are going to create this slider which has to move. So you can see we did the bridging to perimeters, and that printed out a much cleaner print, so this slide moves a lot cleaner up and down. So if I dial through the settings here, you can see how everything prints out. So that was the settings for this particular build plate. Now if I go into my recent factory files and grab my roller setting, this is the one I had to use some support material on, and you're going to need support material because the teeth that engage in the print plate stick out and they're air prints. So you will need support material, and of course on the bottom side of the roller. So if we take a look at the settings for here, I use 30% infill, 0.24 millimeter layer height with 4 top layers, 3 bottom layers, and 3 perimeters. I also did 10 millimeters from the object at 4. For infill, again, our fast honeycomb at 30%. We did generate support material, and I do have our base layer at 1 and our extra inflation distance set to 0 because I use larger support blocks instead of smaller support blocks that actually stick out further. So I create my own extra support infill percentage or extra inflation distance by using some larger support blocks. Again, we're using that Kodak PLA Plus, so 218 to 220, utilizing the full Gmax cooling. For speeds, we printed this out at 45 millimeters per second, and you can see my variables there. We did use the apply bridge settings because there are some teeth and there's a little bit of bridging going on there. And of course, the allow single extrusion fill, one of my favorite settings in Simplify 3D. So if we hit prepare to print, you can see how these slice real quick. And as you can see, with the larger blocks that I've created using the custom support, I'll be able to handle the areas that are going to be supported underneath the ridge of the roller shaft. And as you can see, it is hollow, and using those 3 perimeters make sure that this is super thick, and of course using that 30% infill. So that's the second plate. So now let's look at the third plate, which is the flat parts. Now I dressed these a little bit differently, only because I wanted to make sure that these were a little bit sturdier. Let's take a look at my process settings for these. Again, we have 30% infill, we have a 0.24 millimeter layer height with 4 top layers, 3 bottom layers, and 3 perimeters. We also used our skirt at 10 millimeters from the object at 4, fast honeycomb at 30% infill, no support material. Again, this is Kodak PLA Plus, so 220 and 218 is a great temperature. And we did utilize the Gmax cooling again. For speed, we're at 45 millimeters per second, and you can see my variables there. And of course, we did use the allow single extrusion fill because there are some teeth on the flat plate that we want to make sure are as solid as possible. Now we also have our apply bridging settings to perimeters because I think that's a handy setting to have on. I don't believe there's any bridging settings to worry about in this print, but I left the setting on from a previous print. So if we dial through here, you can see there is a little bit of an error in the 3D geometry here, but I left it alone and it's still printed out and it's still really sturdy. So there were no problems with any of these prints. So once we had everything sliced up, it was time to send everything over to the Gmax 1.5 XT Plus for printing. So let's check out a couple of time-lapse videos that I shot of the parts printing, and then we'll start our assembly. After you finish printing out all your parts, you're going to need to assemble your little printing press before you start printing. And you are going to need a couple little things, as mentioned on the website. You're going to need some M5 nuts and some M5 bolts that are at least 50 millimeters long, so you can tighten up the top roller during the printing process. Now, the assembly was actually pretty easy and it didn't take too long. I did struggle a little bit to get the little nuts to lodge into the little housings in the top of the printing press, but it finally went together pretty easily and I got everything assembled. Now, I did do a little bit of cleanup before the assembly, and that includes cleaning up the areas where the 2 little lock bow tie pieces go in, and for the top part here, just to make sure they fit in super snug. And again, I didn't use any super glue, but you might want to have some super glue handy just in case you need to use it. After that, it was time to prep the printing plates for printing. Now, we did have a couple of methods for creating our printing plates. We had some store-bought rubber stamps, plus we also created our own artwork using Adobe Illustrator, exporting SVG graphics and bringing those into Tinkercad, exporting those as an STL file and bringing that into Simplify 3D, and then we printed those out using Kodak's flexible filament to make our printing plates. Now, I tested out two different design ideas using the Adobe Illustrator to Tinkercad method, and one was more of an artful print, and the other one was using more geometric shapes just to see what I could reproduce using Simplify 3D and the nozzle I had using the flexible filament. And those actually turned out really good, and I was able to actually apply ink to those and get prints out of them. So you can make your own printing plates using some sort of vector art program, exporting those out as SVG graphics, and then bringing them into Tinkercad, and remember to reverse the image because it is reversed image printing, and then export those out as an STL file and bring them over to your favorite slicer, and I would suggest using flexible filament. So now that you have your plates ready for printing, there's one more step that you need to do before you can actually start printing, and that's prepare the paper. Now, the type of paper you want to use for this is handmade paper, preferably white. And you want to do is you want to moisten the paper up a little bit, not really damp and soaking wet. Just lightly blot the paper until it's slightly damp so it soaks up the ink better. Plus, during the compression process, during the printing compression process, it'll soften up the paper a little bit to take on the impression of the plates that you're using. So once you have everything ready, it's time to ink up your plates. Now be careful. This ink is somewhat permanent depending on the type of ink you use. Now I use Intaglio ink, but it is a semi-permanent to permanent ink once it dries, and it does take a little bit of a longer period to dry. So I would suggest using whatever ink you feel comfortable with. Once you ink up your plates, it's time to create the little sandwich that needs to go through this press. Now we cut out pieces of fabric or a felt that we purchased at the hobby store to create a softer surface, which they suggest you do on the OpenPress website. And that creates a small sandwich and a softer surface to slightly compress as you print. Once you have the plates ready and they're all stacked up, all you have to do is tighten down the two screws or the two bolts at the top, and then turn the lever and proceed to move the plate through the printing press. And then once you're done, gently peel everything off and reveal the print. Now, depending on the pressure that you put down using the two bolts at the top on the top roller will indicate how much ink is actually going to transfer. So obviously, the tighter that you make this, the more of a transfer and the more of an impression it'll actually make in the paper, which is really cool. It actually adds a little bit more character to your prints. Once that's done, you're going to have to let your prints dry for a little while before they're ready to show. But once you have some prints out, you're going to want to make as many more plates as you can. And using the vector art to SVG and to Tinkercad method is a really cool method of making your own printing plates. So we've talked about where to download the files, how to print everything out, the assembly, how to prep your plates, and the printing. I'm sure you guys really want to see how the prints turned out, so let's check those out. I am super impressed with the way the 3D printed plates turned out, and I'm actually impressed with the way the rubber stamps work. This is a really cool open source 3D printable printing press, and if you have a little bit of time, you should definitely check this out and print one for yourself. And a huge shout out goes to Martin Schneider, the creator of the OpenPress project. And I'll put his Instagram information down in the description, and you can see all the other prints that some of the other people have gotten from their cool little OpenPress project printers. And of course, thanks to Kodak for sending over some of that PLA+. This is some really strong filament, and it was the perfect choice for our OpenPress project 3D printable printing press. Well, I hope you guys found this episode interesting and informative, and if you're looking for ways to support the channel, check out those affiliate links down in the description, along with other ways to support the channel as well. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll talk to you guys soon. So if you stuck around to the end of the video, I'm going to show you a brief overview of how I created my 3D printed plates using Adobe Illustrator and Tinkercad, and then bringing those files over into Simplify 3D. So here is my basic layout for my first plate that I was going to create. Now I went ahead and created the document size to the size of the plate that I wanted. Now everything on here is basic geometric shapes, and I use Pathfinder to cut out the holes. So if I go to the outline view, which is Command or Control Y on the Mac or PC, you can see all the basic geometric shapes that I used to create this design. So if I hit Command or Control Y again and bring us back to the preview view, you can see all the solids. But one of the things you're going to need to do if you're going to create your own graphics for making your own printing plates with SVG graphics is these all need to be one solid object. They can't be all these parts. So I use Pathfinder, which is an excellent tool in Illustrator to join all the parts together. So once you have everything joined together, you should have a design that looks like this. Now, as you can see, now we have solid shapes that we can use to bring over into Tinkercad and create our SVG extrusion. Now, again, you're going to need to do this very carefully and take your time. One thing I did find out that if you want a little bit of hint, if you're using solid lines like this, make them at least 2 to 3 points thick, or they won't show up in Simplify 3D or they'll be too thin. Another good pointer is maybe not space these objects too close together like I have here. It's a lesson learned, but the next time I do this, I'll know. But this was more of an experiment using vector art to see what I could achieve. And again, I used straight geometric shapes to create this just to see how well our 3D printed plates would turn out using the Tinkercad method. I also created another piece of art, which is this piece here. And I just used a couple of different artistic brushes that Adobe Illustrator has available to create this artwork. And again, you need to expand this artwork or create outlines. So if I go to the outline view, you can see that these are all outlines. Now there is some areas that cross over, and I could probably delete those to keep any vector or polygon issues from popping up in the final. But this was more of an artistic look, so I wasn't too concerned if anything happened as far as error is concerned. The next step you need to do is export these out as SVG graphics, because that's what Tinkercad likes to use best as a vector source. So let's head over to Tinkercad and I'll show you what to do. Okay, so here we are in Tinkercad, and if you're familiar with Tinkercad, this is a really easy process to import graphics and create your own plates. Now, if I select the plate here, you can see the size that I've used. This is 65 millimeters by 140 millimeters, and that gave us a nice size plate to work with, which gave us basically our print boundaries. And it's also 1.2 millimeters thick. Now, the original plate that I did, which you can see here in the background, was 2 millimeters thick, and it just took a little bit longer to print. Now we are using flexible material, which prints at a much slower speed. But I can show you really easy how you do this. If I can just move this graphic off to the side here real quick, and if we just go to the import button, and you can either drag or choose, and we'll go choose, and we'll grab one of our SVG graphics, and I'll just grab this one again. And it has some information here about how you want to import your file. And how you want to import your file is using just the art. So we'll hit import, and it'll take a few seconds, and it's going to auto extrude this, which I think is a nice little bonus. So now that you have your artwork in, it's just a matter of lining it up. So if you rotate it here, and you can hold down the shift key when you click and turn on that little widget, and then you can hold down the shift key again when you click on the red one to scale this down. And then you can move it into position until you get into the right position. So we can go to our top view here, and we can move this around until we're happy with the way it's set up. Now just remember, this is your printing area, so you're going to want to scale this down a little bit so it doesn't go all the way to the edges, because you might have some paper wrinkle or folding. So now that you have that set up, let's go back to our home's position, and let's rotate around here a little bit. You want to address the thickness of this. Now you don't want this to be super thick, so if you click on the extrusion, it's going to tell you how thick this actually is. So let's make sure we're actually selecting this. And you can actually change how thick you want it here. Or you can dial in your setting. Let me move this up so you guys can see this. You can dial in how thick you want it. Now remember, if you're printing with flexible material that's going to take a little while to print, you don't want to have this too thick. But you do want to have it thick enough so when you apply the ink to the roller, it doesn't touch any of the base plate that you're going to put your design onto. So I would say 3.79. You can actually round this to 3.75, and that'll give you a nice thickness. And then of course, make sure once you have that selected, hit the D key to make sure it sits on the floor. Now you can see how thick that is. I might actually bring that down to 3.2, so it's not as thick, because we do have a long print going on. Again, flexible filament. So if you take both of these objects, we drag and select them both, and create a solid out of them, or I'm sorry, group them together, and this creates your solid printing plate. And then you can go to export, click on STL, and export it out to your desired location, and then bring that over into Simplify 3D or your slicing software and set it up for printing. So let's go over to Simplify 3D real quick, and I'll show you how we set this up for flexible filament. Okay, so here we are in Simplify 3D, and we've imported our artwork that we created with the eye. And as you can see, there's a lot of the detail that was lost in the actual translation, but that's okay. This is more of an art piece than a geometric straight shapes. So let's check out my process settings, what I have set up for flexible filament on my Gmax. The first thing I want to show you right off the bat is my extrusion multiplier is set to 1.15. Now that isn't one of the magic numbers, but it is a number that I found that works. And I also have my retraction, coast, and wipe turned off for using flexible filament. For my layer height, I used a 0.24 millimeter layer height with 4 top layers, only 2 bottom layers and 2 perimeters because I want to save as much time as possible. We also ran a brim around the print just to make sure it sticks down to the print bed with 6 outlines. For infill, again, I used my fast honeycomb at 35%, which I figured would be a good base for our top layers. We didn't use any support material. For temperature, this is flexible filament, and I found that 240 to 243 degrees is actually a pretty good temperature for this particular filament, and that's Codex flexible filament. We have our cooling set to a bare minimum because you don't want to overcool the plastic with flexible because it could wisp and get away from the extruder head. For speeds, 15 millimeters per second. Now this is another important note. You want to make sure that your speed is pretty consistent across the board when you're printing with flexible filament, because if you print something very slow and it works good, and then you go to a different part of the print that has a different print setting that goes faster, it could cause some problems with your flexible filament printing. So I try to keep my outline underscore at 100% so it matches it, and then the solid infill down to 90, which isn't too much of a reduction in speed. Now I don't have any bridges on there, so I didn't have any bridge settings. And I did allow single extrusion walls and single extrusion fill for both of my thin wall behaviors for this particular print. And again, I've had great success printing with Codex flexible filament, so those are my settings. So if I hit prepare to print, you can see some of the artwork that actually translated from our original artwork that we created in Adobe Illustrator. And we can tab over and you can see, here's the original artwork, and here's what Simplify 3D, Tinkercad, and the slicing has produced for us. Now you can see it's going to take 2 hours and 28 minutes, but it's only going to use 21 grams of material. And if I dial through this, you can see that with the thinner plate, I'm not getting any infill on this base plate, which reduces our print time and makes a more sturdier plate for the basis of our artwork. So that's the way we did our printing plates from using Adobe Illustrator, exporting those out as an SVG graphic, bringing them into Tinkercad, using Tinkercad to create our base plates or our printing plates, export those out as STL files and bring them over here into Simplify 3D, set up to print with flexible filament, and then send them over to the Gmax 1.5 XT Plus for printing. And those are what we use to create our printing plates for our open press project.